One of the most important things to consider when building or buying a PC is the form factor of the system. Now, usually we start with the motherboard. Over the years, there have been several different form factors of motherboards that have been used in systems. The form factor defines the shape and overall layout of the board. What's important to know is that boards with the same form factor are interchangeable, and this is important or will be important later when you go to upgrade or repair your PC. If you use what we term an industry standard form factor, you'll be able to replace the board that you have with a new one that is different in the future, and usually the new one would be better. What I have here is an assembly of some of the form factors that have been used in PCs over the years, and I kind of wanted to take a tour through the evolutionary changes in form factors and show you what's current today, what you'd want to have in a PC you were buying or building today. Back in 1981, when IBM introduced the first IBM PC, there was no industry standard form factor. They used their own form factor, something that they developed. What happened was, as compatible systems came out, they basically copied IBM's motherboard shape. They built their boards with the same shape, the same connector positions and screw hole positions, so that their boards would be interchangeable in the IBM cases. That was the idea. IBM then changed their motherboard form factor. They started out with the PC form factor and went to a new machine called the AT. This used a larger motherboard. I have some examples of that here. This motherboard, although it is not an original IBM PC motherboard, is the same basic shape and layout of the original PC motherboard. Then what IBM did, in order to have a larger board with more componentry on it, they went to what we call the full-size AT motherboard. That's this one here. Now notice how the two boards are very similar. Notice how the keyboard connector, for example, is in the exact same position. Notice how the slots line up. The screw holes even line up. What happened was, with the new board, they needed more room, so they basically expanded it sideways and in length. This motherboard here was back in the 286 days. This is actually a 286 6 megahertz motherboard, 286 processor. On this motherboard, it took about approximately 100 chips to lay out the circuitry of the motherboard. A few years after this type of motherboard was developed, companies came on the scene with what we call motherboard chipsets. That's where they condensed the 100 or so chips it took to make a motherboard design into something like 2 to 6 smaller chips. With chipset designs, we no longer needed motherboards this big. So what happened was, the industry as a whole shifted back to making motherboards this size. In fact, this motherboard uses a chipset design. You can see the two main chips that comprise the motherboard circuitry on this board. Because we no longer needed 100 chips to make a board, the board size shrunk again. We went back to the original form factor that the IBM PC used, the older machine. So what's kind of strange is we started out with a smaller board, we went to a bigger board, and then we went back to a smaller board design. But the interesting thing is that these are all interchangeable, because the screw holes line up, the connector positions line up, the slots line up. Now, they needed a name for this. This was called the full-size AT motherboard, so the industry just kind of adopted the terminology, calling this one Baby AT, full-size AT and Baby AT. So if you ever hear the term Baby AT, what we mean is a motherboard approximately this size, and this is about 9 by 13, having a single keyboard connector in the back and having slots in these positions, using a certain type of power connector as is shown on this board, etc. All motherboards with a Baby AT design are interchangeable. In fact, you can take Baby AT motherboards and put them in a case that would hold a full-size AT motherboard. That will work also. Of course, it may not be possible to put a full-size AT motherboard in a case that accepts a Baby. There may not be the room. Well, this motherboard design, the Baby AT, persisted for many years. In fact, it was widely used for more than 14 years. Eventually, though, it became obvious that this board layout had some shortcomings, primarily in the connectors on the back. I mean, the only connector on the back of this board is the single keyboard connector. Because over the years, motherboards adopted on board a component called the Super I/O chip. And this chip had built-in floppy controllers, serial ports, parallel ports, hard disk controllers, etc. We needed more connectors along the back of the board in order to plug external devices in.